Have you ever wondered how waters are flowing in the river, how the aircrafts are flying, how liquids, oils are being transported from point A to point B through the pipelines? Yes, all of this exciting stuffs are governed under fluid mechanics. Hello everyone, my name is MD Ajizul Islam Junaid and I will be with you through this entire fluid mechanics course where we will have a brief discussion about the concepts, numericals and different questions, past year questions of the competitive exams. So let's start the journey. So first of all, I'm going to talk about fluids a little bit. What is a fluid? How you define fluid? A fluid is a liquid, gas, or other material that can flow and it can continuously get deformed under a shear force. So suppose you have two objects. Here you have got a solid object and here you have got a fluid. Okay, so you have got two objects. This is solid object and this is nothing but a fluid. Okay, so now if you are applying any tangential stress in both of the cases, the solid object will hold its shape and it will not get deformed. But in case of a fluid, this is a fluid, unknown fluid X, it will flow or it will continuously get deformed because of the action of the shear force. Shear force is also known as tangential force, we know that. So this is the basic difference between a fluid and a solid object. This is a solid object and this is fluid. So you are applying shear stress on it and it is behaving, its reaction is this, that it's starting flowing or it is actually deformed, right? So this phenomenon is observed and that's why we can categorize and we can differentiate between solid and fluid object. Okay, now I want to talk about the characteristics of fluid. So before that I want to give you a brief overview. See, in fluid mechanics we have gas, we have liquids, right? And under the category of this we can see many other subdivisions: compressibility, density, viscosity, vapor pressure, surface tension. In case of density, we know density is rho equals to m by v. M is the mass per unit volume. Viscosity, viscosity is the internal resistance of the fluid against the flow, right? So we will discuss it in more brief manner. So viscosity, in terms of viscosity, we can categorize fluids into two terms. One is Newtonian and the other is non-Newtonian fluid. So Newtonian fluid will be that fluid which will follow the Newton's law of viscosity, and non-Newtonian law will not follow the law of viscosity of Newton. So vapor pressure is there, surface tension is there. Because of the surface tension, we'll get the formula of pressure for liquid jet, then soap bubble, droplet, and so on. So and then we get two broad headings: statics and dynamics. So these two terms are very important in the sense that what do you mean by statics? In statics, the fluid is in rest, right? In statics, the fluid is in rest. So definitely there is no motion. Is there any motion? There is no motion. And there is no force. If there is no force, there is no motion. But in case of dynamics, we are applying force so that we are getting any motion. And we are studying both force and motion under the category of dynamics. But in case of statics, we are not concerned about the force which is causing the motion, right? Okay. So that means in statics, we will have some other topics like stability, some phenomena with pressure, buoyancy, buoyant force, and under the category of dynamics, we will see a laminar or turbulent flow because it's in motion, viscous, inviscid flow, steady and steady flow related to time, and compressible, incompressible flow related to the density. So now this was the overview. Now I want to dive deep into it. So if you didn't understand it with a lot of clarity, don't worry, we will discuss all the concepts from the very beginning, from zero. So now I want to go on and talk about the characteristics of fluids. So let's finish it quickly. Characteristics of fluid: it can be in the form of gas or liquid. there is a large molecular spacing relative to a solid, because in solid the molecular atoms, in the molecular level, the atoms are so closely packed. In case of the fluid, it is actually quite far away if we compare it with the solid. So in case of a fluid, there is a weak intermolecular cohesive force. So can you relate? Because of this weak intermolecular cohesive forces or the van der Waals forces, what is happening is we are applying the shear force and it starts flowing, or it starts continuously deforming, right? I think the fluid will show its behaviors because of the characteristics, right? Okay, so a fluid cannot resist shear stress in stationary state. This is a very important and fundamental uh, characteristic which we can use to define the fluid. So we have been observing this characteristic from our childhood, that the fluids will take the shape of its container, and a fluid is generally considered a continuum. So now, what is this? Why we consider fluids as continuum? In fluid mechanics, we treat fluids as continuum rather than individual molecules, because we are not concerned about the individual molecular level study. We are not able to do that because there are thousands of crores of molecules passing through. So we cannot observe individual molecules. So we actually treat the entire fluid as a continuum. And this assumption is also named. So the name is continuum hypothesis. And why? And is fundamental in deriving the fluid equations like the Navier-Stokes equation. So we will use them. So you will be further clarified in that part of our lecture. So here we can see that viscosity can distinguish different types of fluids. How? Because based on viscosity, we can categorize the fluids into two basic types, which are Newtonian and non-Newtonian fluids. We have already discussed that, and we will also discuss that in the section of viscosity. Okay, so now we want to talk about mass and weight. Okay, so density. What is density? See, density is the quantity of matter packed into a unit volume of material. So it can be measured in kilograms per cubic meter or in grams per cubic centimeter. So density rho is simply equal to mass per unit volume, right? Okay, so mass per unit volume. So this is the formula that you need to remember. So you take the unit of mass as kg, as standard system international standards, and V as meter cube. Meter cube is the standard unit of volume, 3 lengths, right? Okay, so now I want to talk a little bit more. What is the density of water? This is my question to you. I know that 99% students have answered that the answer is 1000 kg per meter cube. But at what condition? At 4 degrees Celsius. And the density of air at 4 degrees Celsius is 1.20. This is very important. You need to mention the temperature. Okay. So now I have written some other points as well. Okay. So see, specific volume. What is specific property? Listen to me very carefully. Specific property means property per unit mass. Okay, specific property means property per unit mass. So that means specific volume is going to be, so say I assume that specific volume is small v, and small v is equal to property per unit mass. That means volume per unit mass. So this will give me 1 by m divided by v, and I will end up getting 1 by rho. So this is my specific volume. And now I want to talk about specific weight. So what is specific weight? Specific weight is represented with gamma. Okay, and gamma is also sometimes you will see specific weight as small w. So let me change the color at first because it's not so much visible. So yes, so gamma or w is the representation symbol of specific weight. So remember, I'm talking about specific weight, and specific weight is equal to the weight per unit volume. It is not weight per unit mass, because if you write m in place of v here, what you will get? So weight per unit mass, you are writing So you will get weight as mg and mass as m. So you will end up getting g. So that means specific weight is g, which is not true. This is not true. So you take weight per unit volume. So this is the standard definition of specific weight. So remember, what is this? This is specific weight. This is specific volume symbolized with small v, and this is symbolized with small w, sometimes with gamma. So what you will get is w equal to mg. We know this formula, and v is equal to meter. Sorry, v is equal to v. Okay, so I will write v, and m by v is rho, and g is in its place. So I got two very important formulas, one for the specific volume, one for the specific weight. Okay, see here I have written the specific weight. So see, the specific weight of water at 4 degrees Celsius is this amount. And how this unit came here, how we get kilonewton per meter cube or newton meter per meter cube. See, gamma can be written as rho g. We have already seen the derivation, and rho into g, right? So what is the unit of rho? Rho is equal to kg. Rho is equal to kg per meter cube. Kg per meter cube into meter per second square, right? So see, kg per meter cube into meter per second square. So see, for example, we have got one here. So I'm writing it again: kg per meter cube into meter per second square. So see, kg into meter, F equal to ma. Kg into meter per second square, sorry, kg into meter per second square, it will entirely give you F equal to ma, means see, kg into meter per second square. So what do you get from here? You get Newton, na? So you can write Newton in place of kg meter per second square. So you got Newton per meter cube. So now you can convert Newton into kilonewton or any other desired unit of your choice. Okay, so we have already talked about specific weight and its unit. You can figure out the units very easily. So now I want to talk about specific gravity. What is the specific gravity? Okay, so specific gravity is the is the density of the fluid to the density of the water at 4 degrees Celsius. Simply, you need to divide it with 1000 if it is talking about the liquid specific gravity. But in case of air, what you would get is, see, as for liquids, what is your value? Weight density or density. So because weight density is sometimes also referred to as density, means density can also be called as weight density. So if someone asks you, if the interviewer asks you a question about weight density, he asks you what is weight density, you should not get confused because both of the terms are actually similar. Okay, so density of the liquid, it will be divided by density of the water at 4 degrees Celsius, which is nothing but 1000 kg per meter cube, right? So yes, so density rho of water by rho of standard water at 4 degrees Celsius. Standard liquid is water, right? Okay, fine. So what is specific gravity for gases? So this is simply density of gas by density of air. So this basic formula you need to just remember. Okay. So see here, we can see that the gases have low specific gravities because gases are less heavy than water, and liquids such as mercury will have a high specific gravity because mercury is very heavy if we relate it with any standard fluid, which is water, right? So 13.2 somewhere in some places it is mentioned as 13.6. So see, the ratio is unitless because in both of the cases we got rho by rho. So kg per meter cube by kg per meter cube will kill themselves. So you will be left with no ratio. So it will be, sorry, you will be left with no unit. So the ratio is basically unitless. So specific gravity is basically unitless, but you have unit in your specific weight as well as your density in your specific volume. You got units, definitely you got units. Like in case of the specific volume, what is your unit? You can very easily figure it out. 1 by rho, the unit of rho is kg per meter cube. So in this case, this is going to be meter cube by kg, meter cube over kg. Okay, so now we have already talked about all the different parameters. So specific gravity is also covered. So now we want to solve a problem. Let's dive into a problem and let's have some fun. So see, it is written that calculate the specific weight. So first what do I need to extract from there? So I am writing solution. So what is given? Density and the specific gravity of 1 liter of liquid. That means 1 liter of liquid, that means the volume is equal to 1 liter. It is given. And the weight, that means W, is equal to 7 Newton. This is also your given parameter. Okay, now I want to see what do I need to find. I need to find specific weight. So specific weight means small w, or gamma equal to what, and then the density. What is the density? Density means rho equal to what, and specific gravity, that means Sg equal to what. So I think that this problem is very easy, so you can very easily figure it out, but you really need to know the conversion of this volume into meter cube because it's given in liter. So we already discussed that 1 meter cube in a 1 meter cube box, cubic shaped box, which is having a length 1 meter, height 1 meter, and the width as 1 meter, you can store 1000 liter water. Okay, so like this, you can remember this forever, right? Okay, so as 1 meter cube equal to 1000 liter, I can very easily convert 1 liter is equal to 10 raised to the power minus 3 meter cube. So I have converted it into 10 raised to the power minus 3 meter cube, and weight is already given in Newton, so I don't need to convert it in any standard parameter. So now see, the weight is given as 7 Newton. So what do you know about weight? Weight equal to mg, and this is equal to 7. So from here you can very easily find the value of m equal to 7 divided by 9.8, right? Okay, m equal to 7 by 9.8. Now as we are required to find the value of rho, which is the density, rho equal to m by v, we have already found the value of v as well as m, so we can easily calculate it. 7 divided by 9.8, and volume is given as what? 10 raised to the power minus 3. So this is nothing but your answer of density. So what is going to be, so we have found the density. What is going to be your weight density? Sorry, what is going to be your specific weight? Specific weight is equal to what? Oh, okay, so specific weight gamma equal to rho into g, if you remember. So rho is equal to what? Already you have found it from here. So rho is equal to 7 over 9.8 divided by 10 raised to the power minus 3 into 9.8. So you can calculate it and you can get the value of the specific weight. So you can also provide the calculated data kg per meter cube. And in case of rho into g specific weight, what is your unit? Unit is kg, sorry, unit is Newton per, sorry, unit is Newton per meter cube, isn't it? Yes, kg, Newton per meter cube. So we have found the value of specific weight, and now you are required to find the value of specific gravity. So specific gravity is equal to rho of the fluid divided by rho of the standard fluid. Standard fluid. So rho of the fluid is already found, and rho of the standard fluid is 10 raised to the power 3. So you can very easily calculate it, and you can check the answers, right? So we have very successfully completed our first problem. Secondly, let's move on. See, calculate the density, specific weight, and weight of 1 liter of petrol of specific gravity 0.7. Okay, so specific gravity of the petrol is given, so I can find the density from here very easily. So specific gravity is equal to 0.7, and specific gravity is nothing but density of the petrol divided by density of water, H2O at 4 degrees Celsius, which is the standard format. So 0.7. So now we can find petrol, rho of petrol divided by 1000 equal to 0.7. So from here we can find rho of petrol equal to 0.7 into 1000. So we can very easily find 700 as our answer in kg per meter cube. So this is the answer. Okay, so we have found the density. So what is the specific weight? Specific weight is also denoted with gamma or small w. So this is what? So gamma is equal to rho into g, Newton per meter cube. So Rho is already found, so 700 into 9.8 Newton per meter cube. So now you have to find the weight. So weight is nothing but m into g, right? So how do you find the value of m? So for m, you need to take the help of rho. Rho is rho of petrol. Petrol equal to m divided by v. So here m, here the v is 1 liter. So 1 liter means 10 raised to the power minus 3 meter cube. And the value of rho is 700. So you can very easily find the value of m from here. M equal to 700 into 10 raised to the power minus 3 kg. So what do you do? M equal to 700 into 10 raised to the power minus 3 into 9.8. So you can very easily calculate it as your answer. So the asked parameters: density, here is your density, specific weight, and weight of the 1 liter of petrol. So every calculations are very successfully done.